Welcome to Complete IT Troubleshooting and Help Desk course. You will discover the IT troubleshooting process, the process that will let you locate and identify failures easily and very quickly, no matter how difficult they are. We're going to talk about IT troubleshooting process standards. We're going also to see how to troubleshoot a failed laptop, how to troubleshoot a failed motherboard, and how to troubleshoot a failed printer. We're going also to study network connection troubleshooting and operating system troubleshooting. We will talk about the definition and working principle of IP addresses, subnet mask, gateways, DNS, and Dynamic Host Configuration Protocol (DHCP). This course is for anyone who wants to master the skill of troubleshooting. Plus, we're going to see the IT troubleshooting definition. So, troubleshooting is the process of finding the cause behind a failure. It does not mean solving the problem, but it means identifying the cause of the problem. IT troubleshooting process. By understanding this process, you can identify and fix any IT problem, no matter how difficult the problem is. With these 7 steps, you can solve any IT problem you might encounter, whether it's hardware, like troubleshooting a computer or a printer, or software, like troubleshooting a network connection or an operating system. These steps are analyzing, testing, deduction, elimination, isolation, identifying, and fixing. We're going to see in the next classes the definition of each step and how can we use it. Analyzing. Understanding the working principle of a device, group of devices, or software that we want to troubleshoot. The goal of analyzing process is to determine the suspect components. Testing. Testing is one of the most important troubleshooting standards that help to locate and identify the cause of a problem, especially when troubleshooting hardware failures. Deduction. The logic by which we analyze the results of the testing standard. Elimination. The process of removing parts that are not suspected of being failed. Isolation. Isolation is one of the most important and indispensable pillars of IT troubleshooting. Its goal is to minimize the number of suspect parts as much as possible. In this process, we can deal with 2 types of isolation: hardware isolation and software isolation. So, hardware isolation is the electrical separation between 2 electrical circuits or electronic components. Software isolation is the separation between 2 software programs, for example, of operating system and driver. Identification. Identification is the process that comes directly after the isolation process, and its goal is to identify and locate the cause of a particular failure. Fixing process. Identifying the problem is the main purpose of IT troubleshooting, and the ultimate goal is to fix it. The fixing process is done either by fixing the cause of the problem or completely by changing the failed part, especially when it comes to hardware. Note: understanding and following these troubleshooting standards is the secret of IT troubleshooting. Types of logical isolation. In this class, we're going to see two types of isolation: inclusion mode and exclusion mode. So, the inclusion mode is based on the analysis and diagnosis of a workstation or major component within a group of components. Let's assume that these are the suspect components A, B, C, and D, with D as the major component. So, using inclusion isolation, we will focus on troubleshooting this part, D part. So here we have a real example with 4 suspect parts: plug, power cable, 19-volt adapter, and laptop. So inclusion mode or inclusion isolation will be applied directly to the laptop. For exclusion mode or exclusion isolation is based on the analysis and diagnosis of components of a set except for the main component. In our example, as you see, these are the suspect components A, B, C, and D, or plug, power cable, 19-volt adapter, and laptop. So, by performing the exclusion isolation, the major component in our case is the laptop. So, this laptop will be replaced with another in order to check its serviceability, and then identify the failed component. Troubleshooting training. In this training, we will see the most 5 important IT troubleshooting topics. We're going to study and troubleshoot a failed laptop. We're going also to see how to troubleshoot a failed computer motherboard, how to troubleshoot a failed printer, how to troubleshoot a network connection. We're going also to see how to troubleshoot a failed operating system. So, let's get started. Troubleshooting a failed laptop. The first level of troubleshooting. So, let's assume that this laptop does not turn on. So, how can we troubleshoot this failure? So, as you see here, this is the laptop. Here we have the adapter. Okay, this is the 19-volt adapter, and this is the power cable, and here we have the plug, the source of power. And here we have the troubleshooting tree that we will use in the troubleshooting. So here we have the laptop, okay? And here we have the power button. So the first action that we should do is to press the power button of the laptop. If we press the power button and the laptop is turned on, then it's okay. If not, means if we press the power button of the laptop and the laptop still off, we should check the adapter, the 19-volt adapter. So if we replace the 19-volt adapter and the laptop turned on, that means the problem is in the adapter. If we replace the 19-volt adapter and the problem persists, the laptop still off, so the problem is not in the adapter. We should check the power source. And if we check the power source and we find that the power source is not okay, means the power is absent, so the problem is in the power source, not in the laptop. But if we check the power source and we find that the power source is okay, that means the problem is in the laptop itself. See you in the second level of troubleshooting in the next class. The second level of troubleshooting. So, we're going to continue troubleshooting a failed laptop does not want to turn on. So, this is the path that we will follow to troubleshoot this laptop. As you see, here we have the plug with 230 volt and 60 Hz or 115 volt and 50 Hz. This is two terminals of the power cable. And here we have the adapter. This is the 19 volt DC adapter plug. And this is the laptop jack. So this is another image for the laptop jack connected to the motherboard. And this is the power button. Okay? So where your laptop won't turn on, the problem can be in one of these items. Maybe the plug, maybe the cable, the power cable, the laptop adapter, maybe the jack, the laptop jack, or maybe in the power button. If you find that all these items, when you do your troubleshoots, and you find that all these items are okay, so the problem is in your laptop itself. So here we have the troubleshooting tree that we will study. So here we have the laptop. So this is the power button. So when we press the power button, we have two states. The laptop turned on or the laptop still off. If the laptop is off, we should check the adapter and the power cable. If we replace the adapter plus the power cable and the laptop goes on, then the problem is in the adapter or the power cable. But if we replace these two items and the laptop still off, then the problem is in the power source. We should fix it and we will solve the problem. But if we find that the power source is okay, so we find 230 volts or 115 volts, but the laptop still off, so the problem is in the laptop itself. So we should check in the first time the power jack. Maybe the power jack is failed. Maybe there is a crack in the power jack or a dry in it. You should check the solder, the power jack pads, if its pads is connected correctly to the motherboard or not. So if you find that the power jack is okay, so in the second time you should check the power button. Maybe there is a problem in the power button. If the power jack is okay and the power button is okay, so the laptop motherboard is failed. You can replace the laptop motherboard and you will solve the problem. But in the next class, we will see the third level of troubleshooting. We will see how to troubleshoot a failed motherboard. Welcome to the third level of troubleshooting. As we have seen before, if we find that all these items are okay, in a good state, and the laptop still off, the laptop motherboard seems to be failed. So how we can check the laptop motherboard? So the first thing that we should check is the power jack, as you see. So this is the power jack, okay? So we should first check the power jack because the power jack is the input of the power to the motherboard. Okay, so this is the first item that is connected to outside world. Okay, so we should first and we have to first check the power jack. How can we check the power jack? I'll show you how. So using the multimeter, so put the multimeter to DC voltage option, okay, and then using the terminals or the probe of the multimeter goes to the back of the motherboard and locate the pins of the power jack as you see. So we have here 3 pins, okay, so this pin and this is the same, okay, so this is ground, okay, this is low pins and this is the high pin, okay. So you should check first that these pins is connected correctly to the motherboard. Okay, you should check that there is no dry or crack or something like that. Confirm that the pins are connected and soldered correctly to the motherboard. And using the multimeter, you have to check the 19 volt. So you have to put the black probe in the ground terminal of the power jack and put the red probe of the multimeter to the high pin of the power jack, and then you should measure the 19 volt or 18 volt in accordance with the type of the adapter. Okay, so if you find a voltage between these two terminals, that means the power jack is in good state. Okay, so the problem is not with the power jack. We should go and check another item. So if we find that the power jack is good, we should check the power button. Maybe there is a problem. The power is get into the motherboard, but maybe there is a problem with the power button. We should check the power button. So how can we check the power button? Show you how. So as you see, this is the power button, okay? So if you disassemble the computer or the laptop, you will find the power button, and this is the power button pins. Actually, the power button have 4 pins. So 2 low pins and 2 high pins, okay? So, and this is the schematic, the power button schematic, as you see here. So if you check using the multimeter the 2 pins of the power button, you have to find 3.3 volts. Okay? Without switching on the computer, you should find 3.3 volts between the terminals of the power button. As you see, this is the schematic of the power button. As you see, so this is the power button. Okay? This is the high terminal, this, and this is the low terminal that is connected to the ground, so this terminal. So when you check the power button using the multimeter, you will find here 3.3 volts, okay? And if you press the power button, this 3.3 volts should be 0 volt. Why? Because it will go through this button to the ground. So to check if the power button is good or not, you should first measure 3.3 volts, and when you press it, this 3.3 volts should disappear and goes to 0. Okay? So if you check the power button and you find it okay, so the problem is not in the power button, is not in the power jack, the problem is in the motherboard itself. So we have here the troubleshooting tree. As you see, we have the laptop, we have the power jack. So if we check the power jack and we find that the power jack is bad, we can just replace it and we will solve the problem. But if the power jack is good, so we should check the power switch. Okay, so if we check the power switch and we find 3.3 volts, then the problem is not with the power switch. The problem is the motherboard. So the motherboard failed. we should replace the motherboard. But if we check the power switch and we find 0 volts, that means the problem maybe is in the 3.3 volt motherboard circuit. We should check the 3.3 volt motherboard circuit. Okay? If we check the 3.3 volt motherboard circuit and we find it bad, then we should replace the motherboard. So in the next class, I'm going to show you how to check the 3.3 volt motherboard circuit using its schematic. The 3.3 volt motherboard circuit. So, as we have seen in the previous class, in the third level of troubleshooting, we have seen that if you measure 0 volts instead of 3.3 volts in the power switch, then the problem seems to be in the 3.3 volt motherboard circuit. Normally, in the high pin of the power button, you should measure 3.3 volts even if the computer is off. But if you don't find 3.3 volts, this means that the problem is in the 3.3 volt motherboard circuit. So in this class, we're going to study the 3.3 volt motherboard circuit schematic in order to know what can be the cause of the failure behind the absence of 3.3 volt in the power switch. So let's get started. So as you see here, this is 3.3 volts and 5 volts always circuit diagram. So as you see here, this is the 3.3 volts. Here we get the 3.3 volt, as you see here. And this is the IC that is responsible for this 3.3 volt, as you see here. So this is the IC, the PU2, as you see. This is the maximum or max 8778. So this IC is responsible for generating 3.3 volts. Okay, and also here we have two MOSFETs. Okay, that works with IC, and here we have a coil, as you see, PL7. We have some resistor here, and this is a PF capacitor, and here we have a chemical capacitor. This capacitor is a filtering capacitor. Okay, so how can we get this 3.3 volts always? I'll show you how. So as you see here, so in the beginning of the circuit, we have here the power source. As you see, the power source, here we have 19 volts. So this point is connected directly to the power jack of the motherboard. So here we have the 19 volts, okay, and here we have a coil, as you see, coil. So here we get here the 19 volts. Also we have here the DC power source, as you see. So this 19 volts will pass through this PF capacitor. So this is a filtering capacitor, and will go directly and pass through this resistor and then go to this IC. As you see, we have here the VN, so the input voltage. Okay, this is the 19 volt VN voltage. Okay, so the 19 volt will go here to this pin number 6 of the IC, and also will go directly to the drain of this MOSFET. As you see, this is drain. So using the multimeter, you can measure and check whether this 19 volt is present or not. The first thing you have to do when you troubleshoot the 3.3 volts is to check if the 19 volt exists here and also in the drain of this MOSFET. As you see, the PQ7. This is just an example, but the working principle is the same. You can do the same with any schematic and any laptop. Okay, so the first thing is to check the 19 volt in the VN in this pin number 6 for this IC, the max 8778, and also in the first MOSFET. So if you find 19 volt in pin number 6 of this IC, and you find also the 19 volt in the drain of this MOSFET, and you check all these components, this resistor, this capacitor, and also this capacitor and this coil, you can check if this coil is okay or not using the multimeter. And the buzzer option, you can check this coil. So when you put the red probe here of the multimeter and the black probe here, and you hear a sound or a buzzer, that means this coil is okay. So if you check all these components, so this capacitor, resistor, and the coil, and also these MOSFETs are okay, and you have the 19 volt here and the 19 volt here in the pin number 6, and the 3.3 volt still absent, that means maybe you have a problem with this IC. Okay, you can confirm by going and checking the plus 5 volt. Why? Because this IC is responsible for generating 3.3 volt always and plus 5 volt always. Okay, so if you find the 3.3 volts is absent, you can go and check plus 5 volt. If you find also the plus 5 volt is absent, that means the IC can be failed. But if you find here plus 5 volts exists and 3.3 volts absent, maybe you have just a problem in one component in the 3.3 volt part, maybe a resistor, maybe a capacitor. Okay, maybe this coil is failed. You should just check this part. So remember, if you have all these components are okay and you don't find the 3.3 volt, maybe the problem is the IC itself. Okay, I want to add that this IC and these two MOSFETs is the main component that is responsible for generating 3.3 volt, because this IC controls these two MOSFETs, as you see. So this is gate. Okay, so we have the gate of MOSFETs, as you see. So here in the pin 26 you have upper gate, okay, and here in the pin 23 we have the low gate. So this IC controls this two MOSFET in order to generate this 3.3 volt always. So if you find that this MOSFET is bad, you can change it and you will solve the problem. If you change this IC and the problem persists, you have to change the whole motherboard and you will solve the problem. So by checking the 3.3 volt motherboard circuit, if you find a failed component, you can just replace it by another serviceable one and solve the problem. But if you find that the 3.3 volt always is complex to solve, you can just make things easier and replace the whole motherboard. Before diving into network connection troubleshooting, let's first understand some concepts. So, first of all, we're going to see what is an IP or Internet Protocol, what is a subnet mask, and how subnet mask works. We're going also to see what is a gateway and how do a gateway works. We will also see what is a DNS, how it works, and what is its purpose. So, let's get started. IP address definition. An IP or Internet Protocol address is a unique address that identifies a device, computer for example, on the Internet. IP addresses allow information to be sent between devices on a network. They make devices accessible for communication. The Internet needs a way to differentiate between different devices, routers, computers, and websites. IP addresses solve this problem by providing a way of doing so. An IP address is a group of numbers separated by periods, exactly 4 subgroups. As you see over here, this is the format of an IP address. We have the first group, the second, the third, and the fourth. An example of an IP address might be 192.168.10.1. Note that each number in the group can range from 0 to 255. So IP address range can be from 0.0.0.0 to 255.255 four times. IP addresses are produced and allocated by the Internet Assigned Numbers Authority (IANA), a division of the Internet Corporation for Assigned Names and Numbers (ICANN). It is an organization that helps maintain the full security of the Internet around the world and allows it to be available for all people. How do Internet Protocol addresses work? Internet Protocol IP works the same way as any other language. All devices exchange information with each other using this protocol. Note: IP addresses process happens behind the scenes. What is a subnet mask? A subnet mask is a number with the same format as an IPv4 address. It consists of 4 sections of 1 to 3 numbers separated by dots. Each section or group can contain a number from 0 to 255, exactly like an IP. For example, 255.0.0.0 allowing for up to 16,777,216 IP addresses. This format of subnet mask, as you see, called a class A, as you see, we have just one section is full and we have the 3 sections are empty. So the formula that we use to get this number is this: 256 times 256 times 256. So another example, we have here 255.255.0.0 provides up to 65,526 IP addresses. So this is the class B network. As you see, we have 2 sections are full. So this is the formula that we use to get this number, because we have here 2 sections are empty. So the third example is a class C network with 255.255.255.0. It provides 256 IP addresses because the 3 sections are full. We have just one section here. So from 0 to 255, we will get 256 IP addresses. For the fourth example, we have, as you see, 255 3 times dot 250. So this subnet mask allowing just 6 IP addresses, as you see. So 250, 251, 252, 253, 254, and 255. So just 6 IP addresses. A subnet mask defines a range of IP addresses available within a particular network. So its goal is to limit the number of valid IPs for a specific network. Understanding how subnet mask works. So let's take an example. Let's assume that a subnet mask defined as this format. So 3 sections are full, dot 0. Okay, so we have 3 sections as you see here, and the 4th section is empty. We have just 0. So the first 3 groups are full. meaning the IP addresses of devices within that subnet mask must be identical in the first three groups. Why? Because the tree section of our subnet mask is identical. So the IP addresses of devices within that subnet mask must be identical in the first three groups. The last group of each device's IP address can be anything from 0 to 255. So the IP addresses 125.12.25.7 and 125.12.25.15 are in the same subnet mask. Why? Because these three sections are the same as our reference here. But 125.12.17.8 is not. Why? Because we have just two sections are meet our condition, but the third section is not. A specific network that is configured with a very limited subnet mask, example of 255.255.255.230 is limited to 26 IP addresses, which means that only 26 computers or devices can be connected to this network. Why? Because here we will begin from 230 to 255, so limited to just 26 IP addresses, which means only 26 devices can be connected to this network. Most of the time, this subnet mask with three false sections is the default subnet mask for the home network and small companies. What is a gateway? A gateway is a device that works as a gate or bridge between two networks. It may be a router or other devices that enable traffic to flow in and out of the network. All data have to flow through the gateway before coming in or going out of the network. The gateway may also convert information or data from one protocol or format to another. Gateway examples: a router. It is a common type of gateway used in home networks and very small companies. It allows computers and devices within a specific local network area to send and receive data over the internet. Firewall. A firewall is a gateway that filters incoming and outgoing traffic, blocking data coming from suspicious or unauthorized sources. Proxy server. Proxy server is an advanced type of gateway that filters traffic between two networks. It may only allow local computers or devices to access a list of approved and authorized websites. Domain Name System (DNS). A DNS is an Internet directory, exactly like a phone book. Users access the Internet through domain names, such as google.com or youtube.com. DNS translates domain names into corresponding IP addresses. Every device connected to the Internet has an IP address that other devices use to find it. The main purpose of the DNS servers is to eliminate the need for Internet users to memorize IP addresses. Dynamic Host Configuration Protocol (DHCP). DHCP or Dynamic Host Configuration Protocol is a network protocol that is used on the Internet Protocol (IP) networks for automatically managing and assigning IP addresses to computers or devices connected to the network. Notes: the purpose of this advanced technology is to eliminate the manual configuration of devices. All recent gateways and routers have DHCP server compatibility. Troubleshooting a printer. So, in this class, we're going to see how to troubleshoot a failed printer that is connected to a network. So, as you can see here, this is a printer and this is the network, and here we have the laptop. So, we can troubleshoot this printer using two modes or two ways. So, we have the inclusion mode that we have seen before. So, using inclusion mode, it will base on the analysis of the major component within a group of components. So here, this is a group of components, and the major components is the printer. So using the inclusion mode, we will focus just in troubleshooting and diagnosis this printer. The first thing that you should do is to turn off and turn on again the printer and check whether the failure is disappeared or not. If the failure still persists, you can check the power cable for the printer and also check the network cable or RG45 cable. Okay, once you do all this and the failure still persists, you can go to the next mode, the exclusion mode. So the exclusion mode is based on the analysis of components of a set except for the main component. So as you see here, so this is the diagram that you can follow to troubleshoot this printer using the exclusion mode. So as you see here, this is the main component. So we will not focus in the suspect printer. In the exclusion mode, you will use another printer, as you see, to be sure if the problem is in the major component in this printer or in the other sets. So you can just use another printer if the problem is solved. Then the cause of the problem is the printer itself. If you use another printer and the problem still persists, then the problem is not in the printer. Maybe there is a problem with the network or with the laptop itself. So you should check your laptop or your computer and confirm if you have the printer driver. Also check all cables, so the network cables, and also you have to configure the IP addresses. This is two modes that you can use to troubleshoot printer or a failed laptop. Anything you can troubleshoot, you can use these two modes: inclusion mode and exclusion mode. Troubleshooting and network connection. So here we will talk about how to troubleshoot a failed network connection. So as you see here, this is a router. We have here a laptop, okay, and this laptop is connected to this router using the network cable. As you see, this is the network cable or RG45 cable, okay. So for example, if you don't have the connection in your laptop, maybe you have problem in the router itself, maybe in this cable, maybe the cable is not connected correctly to the router or to the laptop itself. If you cannot receive the connection in your computer or in your laptop, how can you check and find the cause of the problem? First of all, you should check your router and be sure that your router send a good signal. And second, check your cable. This is a network cable. You should check that the cable is connected correctly to the router, okay? And also is connected to the laptop in the other side. So If you don't solve the problem by checking all this, you should go to router configuration and check if DHCP is set to automatic. So if your DHCP is not set to automatic mode, you should configure your network manually. You can also reset your router and check again. Okay? When you use a switch as a bridge between the router and the laptop, this is the same principle. If you have a failed network, there is 4 items that you should check: the router, the cable or network cables, okay, and the switch and the laptop itself. So if you check your router and you find that DHCP is set to automatic mode, and you should check your switch or cables are connected correctly between switch and the router, also, and between switch and the laptop. Okay, if you check all that and the problem still persists, you can just turn off your router and then turn it on and check again. Basically, if the DHCP is set to automatic, you will not get any issue or any problem. All IP's configuration between router, switch, and laptop will be set automatically. Now, when your laptop is connected to the router via a Wi-Fi, so the same principle, always you should check that the DHCP is set to automatic, not manual. And then you should activate the Wi-Fi on your laptop by using the Wi-Fi key or button in your keyboard. So you should activate your Wi-Fi in your laptop and then check if the DHCP is set to automatic, and automatically your laptop will detect the Wi-Fi. Troubleshooting an operating system. So, as you know, the operating system or Windows is the most important software in any computer. So there is operating system, programs, and drivers. Okay, so the operating system is Windows, and the programs is the application that you install after you set up your operating system, and the drivers is the interface or the bridge between the operating system and devices. The devices cannot be operated correctly if you don't have drivers. Each device has its own driver. So if you look to this diagram, as you see, so we have here the operating system, okay, and we have drivers, as you see, and we have the devices. So always the operating system is the main software that make program, driver, and devices work correctly. If you have, for example, a movie in your laptop and you want, for example, to watch a movie that you have in your desktop, first of all, you should have an operating system installed, for example, Windows 10. And to see or to watch this movie, you have to have an application, a video application, for example, VLC application, and also the driver for your graphic card must be installed. The same working principle for the sound. So if you don't install the sound driver, you cannot hear anything in your computer. The same thing for the keyboard, HDD, and printer. So all devices connected to the computer should have a driver in order to work properly. So operating system is Windows, like for example Windows XP, Windows 7, Windows 10, etc.